So once we write down this kind of code, SQL code, in our database system and runs it, the system will do is to create an empty table or blank table for us. Something like this, we can jot down it as shown here. So once we run the code like this, as shown here, the system will generate one table. This table has no data inside it. It has only the table name. The table name will be product, right? And this product table has columns. The first one is name. The second one is price. Third column is category. And last column is the manufacturer. So once we run the code as shown here, the system will generate one blank table for us as shown here, like this, right? And besides generating or create a table, we can also actually delete a table in our database system. It's equivalent to remove a relation from our design. So we can do so by typing in the job table with the table name and something like this. We can still take the products table as an example. So we know if we run the code like this, the system will generate a blank table, and as shown here. And later on, we can insert some data into the table. It's fine. And however, later on, you find that we need to make some changes to the relation. You think this table is not necessary, and you plan to delete it from your system. You can do so by typing. You can do so by typing job table product with semicolon for it. You can do so by typing this code job table product, and the system runs this code. What the system will do actually is to delete the whole table from the system. Once this code is run and it finishes running, and this table will be deleted and will no longer exist anymore. Here I mean both the table schema as well as all the data inside this table, they will all be deleted. The table will no longer exist. So if you run this code, please be very careful if you plan to job some tables. So once the table is jobbed, both the schema together with the data, they will all be deleted and can never be recovered. So be very careful if you plan to run code and job table like this. So you see, when we are creating a table or relation, we have to declare the types of attributes inside this relation with some data types. The data types we can use in our database systems is very similar to our programming language like C++ or Java, but they also have some differences. So in this page, we're going to show some very common data types we can use in declaring the relations and the tables. So we see that the principal element of the attributes actually is a pair consisting of attribute name with a type. And the common types we can use to declaring the attributes actually include the integer, as we show here. We can write down either as an int or integer. Depending on the system we are using, they can be the same actually. And for the real numbers, we can either write down them as a real or float in our system. We also mentioned that we have two different ways to declare the strings, right? We can either write down them as a char with n is a number. This denotes a fixed length string with n characters. So if you see some of the string are fixed length, we have some cases like VRN number or the passport numbers or the social security number. The length of the strings is a fixed length, right? If so, then we have to declare them as a string of a char n, right? A fixed length string instead. And sometimes the string we have in our database system can be changing, right? For different cases. Now for the names of a person, the name can be different for different person, right? If so, then we can declare the name of a person as a var char n. N is also a number. So it denotes a variable length string with up to n characters inside the string. So this n denotes the maximum length of this var char string. So you can differentiate these two, right? This char denotes a fixed length string with n characters. This var char n denotes a variable length string with up to n chars. So they are different. And let's come back to the example we showed before, right? We show an example on this page. We say that for the products, we can declare the name of the products as a char. It means that for all the products in our tables, they should have the same names, which is 20 chars as a name. However, in the real world, probably it is not the case, right? Because the name of the products can be very different. And then we probably have to change this one to var char instead, right? var char 20, it means the next length of the string is 20. If it is shorter, that's fine, it's okay. And we also have to update this name here, it should be var char, right? For category, we could declare this one as the var char is fine. Manufacturer is also var char, that's also fine, right? So for some cases, we have to use a char. And some cases, we have to use the var char. And the common way we can use the char is for some ID numbers, like the driver's license number, right? Social security number, and with the passport number. Even your FSU ID and something like this. So we have to use a char for us. The main reason is because for this kind of numbers, they have a fixed length. We cannot declare them as var char because they are fixed length. We have to declare them as a char. In this way, the system can help us to check if these input numbers they are legal or illegal in terms of their length. So we know that like the social security number, this length is 9, right? If we type in some numbers whose length is 8 or 11 or 10, then we can say that it is illegal. In the system, we reject this kind of data inputs. Therefore, for some cases, we have to use the char n to help us to check some data inputs. It should be of a fixed length. And sometimes we have to use the var char. It is more flexible. Like the names or some other cases, we have to use the var char as shown here. So all these types we show here has their specific functions in the real world in modeling the data we have.